I will hand you over to our first speaker, who is Ralf Weber for Nominum. And Ralf is going to be talking about a worrying new type of attack on and via the DNS infrastructure.
Good morning. Can everybody hear me? Hope you had a good day yesterday. And so the topic today is random subdomain attacks. That's a new type of DNS DDoS based attacks. I spoke at the Manchester UKNOF about amplification and how they are used to use DNS as a vector for an attack. And that's now actually a thing of the past. The amplification attacks are still there, but they are on a much lesser scale. The new thing that we have here is basically random subdomains attack, and they are not only kind of targeting a client that they want to turn out, but they are actually targeting the authoritative server for a domain, and with that sometimes bring down the resolvers. So the attacks look like these. So, oops, okay. Pointer, yeah. So there's the actual target domain, and then in front of the target domain there's a random part. And that random part actually never returns an A record or something useful. It always is an X domain, which is often an answer that is harder for an authoritative server to give than giving back an A record. And the random patterns really, caching isn't the point because they're random, and every query you get is different. There's not a single query that is issued twice. So resolvers have, for every query go out to the authoritative servers, get the answer, then the authoritative servers always have to give back the answer. So it's a constant flow of traffic between them. And of course, if you would do that on your own, it wouldn't be fun because you could easily be detected. But because UDP is kind of stateless and can be easily spoofed, people muster other resources. So in total, the attack works like this. We have these open DNS proxies that are around the world. I think the current number is around 20 million. And somebody is actually asking these open DNS proxies for the domain. And that DNS proxy then says, okay, I don't know anything. I'm going to ask my ISP's resolver. And the ISP resolver will, of course, do what it is supposed to do, try to get an answer for its client, because to him, this open DNS proxy appears as a legitimate client. And then the authoritative server kind of comes back with an answer that is sent back, but the send back is not an issue because in contrast to the amplification attack where the response was quite large, here the response is an X domain, and most of the domains are not signed, so it's a couple of bytes, so it really actually doesn't target anyone. The response doesn't target anyone. The target of this really is the authoritative server, because if the authoritative server of a website dies, that website is pretty much offline. So, and OpenDNS proxies is something we worked a lot with the Open Resolver project, so special thanks to Jared Mauk here again. We are doing a scan every week of the whole IPv4 internet, or Jared does, and we kind of collect the results. And we're doing since March this year, and the numbers have come down, so they were 26, 27 million, they're now around 20. But still, 20 million of these is a lot. And if you think if any of these can just do, say, 1,000 QPS, that's a hell of a lot of traffic that you can generate on the internet. And the breakdown currently, that's the last scan from last week, is around Europe. So the UK has 1.9 million still. The other countries, you can see Ireland is not as much. Someone sneaked in Australia there, so sorry, that was my mistake probably. It should be AT for Austria. Anyway, so these are the numbers that are still out there and can be used for attacks, but it really doesn't matter which country the attacks are, because you want to globally bring down something. And so I want to talk now about how we discovered this. So we collect traffic from a lot of our customers. So our main software is a recursive resolver, DNS resolver, and that is used by telcos and ISPs around the world. And from some of them, we get traffic, anonymized, so that we actually cannot see their clients. But we generate reports out of that. And one report that we do is how many unique domains were actually asked. And that was around 70, 80 millions that we saw from customers around the world. And that started to grow dramatically over the last month. So you see, here it's over 200 million, and we even saw numbers over 1 billion, basically unique domains. That means kind of these random subdomains attacks, these randomness in the beginning are really in the millions or tens of millions. And if you have something like 100 or 1,000 domains being attacked that way, it's a huge number of unique domains. We even had problems sometimes with kind of generating this report because the memory requirements for generating were quite high. So that's how it works kind of in a more logical way. So you see the NXDs getting sent back. Now, of course, one thing we said a year ago or so that people should do because of the amplification attack was to do truncate. So authoritative servers who now truncate because they are getting lots of traffic from one IP, which is a legitimate resolver of an ISP, they will actually have 3 times the traffic because, TCP, switching to TCP requires an additional round trip. So you have a lot of more traffic if you actually truncate. And the effects if you drop are even worse. I'll come to that later. And if you kind of then put enough traffic onto the resolver who then will put that traffic on the authoritative servers, you will at one point kill the authoritative. And we've seen this a lot of the times where really servers under load, sometimes they'll stay alive 5 or 10 minutes, but then they just die. And that's not even small ones. So the names that are attacked have changed. In the beginning, it was really just obscure Chinese gaming sites, so really not a lot of people cared. But recently, the attacks have also changed to attack some more popular domains, and for me, it's only a question of time then when they maybe will try to attack something even more popular. So, and some of the domains were hosted by kind of pretty popular CDNs, and so they can withstand probably a lot more. And I mean, even up the infrastructure, people can withstand quite more, but you will still kind of have all that useless traffic flowing around, and you have to provision your service for all that useless traffic. So the internet has become a very naughty place. I'm going to talk about how we can maybe do something about that shortly. As said, the current, that's just some examples we did on the randomizing. So far, the randomizing has been pretty static. Well, it's random, but it's the algorithm has been pretty easy to digest, so there hasn't been any kind of too much thought put in so far. So currently, when we analyze these traffic, we can identify these domains pretty quickly because the randomization pattern is pretty easy to digest. And another thing is that these attacks are coordinated worldwide. So as said, we collect traffic from ISPs around the world, and here are the QPS pattern, because in the end, you want to push as much traffic as you can. So the QPS that these servers handle really spikes in that case. It's not like with the amplification attacks, the QPS was gradually increasing, but the response sizes and the bandwidth was much. With these, they're really just, these attacks are very spiky. So they start coordinated around the world. So somebody is using a server to, or a couple of servers to target all these open DNS proxies around the world at one point in time. And as soon as the server dies or is dead, the attacks kind of ease off. So they are very coordinated, very sort of intelligently monitored also, but they of course have a huge impact on the resolvers and the authoritative servers. And the resolver impact is, if you, monitor your resolver closely, there's one thing that you are always worried about, which is called recursion context. It's basically the numbers of outbound recursions. So how many authoritatives you are currently asking. And that slide is something like 40K. So that means 40,000 outbound recursions are open every second of the server, and just because of these attacks. And of course, they come down. But if your resolver has a limit on that, everything above that, of course, is dropped or is not recursed. So your internet service that you provide becomes sort of degraded. You still can provide some resolutions, but it's not deterministic which resolutions you actually are providing. And as soon as the attacks are coming down, they can come down again. So these number has been, because of a couple of reasons, increasingly over the last year, because the DNS resolution has become much more dynamic over the last probably decade or so. So I know I used to run servers that had max recursion limits with thousands, and we advised our customers for the last year or so 20,000. So this is, a customer had an attack who doubled the amount of recursion contacts. Recursion contacts in DNS servers cost memory, and it's not as bad as it used to be, but still it is a resource, and you also need to manage the resource. And of course, not only memory is impacted, but also the CPU is impacted, because if you are putting out a UDP packet, and UDP, as you know, is stateless, you have to wait for the response and then kind of look, is the response corresponding to that the courier sent, and so the CPU also gets to do much more than it would if it wouldn't have to do that stuff. So let's think about how we can basically do something about it, and what we have basically had in the past. So last year we said basically, well, truncate or drop traffic if you are not having any use of the traffic, and that was mainly for the amplification attacks. But the problem with these attacks is that they are not coming from illegitimate clients. They are coming from your ISP's resolvers, and authoritatives usually want to serve ISP's resolvers because that's how they get their traffic to their website. And anything that we thought about on the authoritative side, where we thought the client was illegitimate, we can basically, we have to do new tactics there, because these tactics don't work anymore. And even stuff that is proposed, like, DNS cookie is an interesting idea, but it's an interesting idea between a legitimate resolver and an authoritative. And for these kind of attacks, all the communication is between a legitimate resolver and an authoritative. So it won't help there. And as I said, the resource rate limiting, which was a good idea for the amplification attacks on the authoritative side, it's not a good idea for this attack, because it makes stuff worse, because you have to do TCP, or there's one thing that we internally call the Friends of Sleeping Bear problem, because there was a domain that is a kind of a beach somewhere in the US that has a website, and the website was hosted by Cloudflare. And Cloudflare also hosted other websites, and one of their websites was attacked, and to sort of defend the attack, they said, well, we're not going to answer this anymore. So what happened was then basically the resolver said, this name server doesn't answer me anymore, so I'm not going to ask it any longer. And all the domains that were on that name server, I'm also going to ask them, because I know that name server is not answering anymore. So there has to be some stuff done also in the recursive to maybe make that logic better. But the problem with all that logic in the recursion process is it's very kind of costly, because one of the things if you're building a recursive resolver is you want to get the answer back as fast as you can. So any piece of logic and any instruction that you have there basically makes your response time longer, and you want to make it as short as possible. And so good caution has to be taken in kind of doing anything on the recursion side of it. There might be some solutions there, maybe we hear about them later, but it is very kind of, you have to be very careful when you're dealing with that. And another thing with these kind of attacks, there are really cascading failures. So the authoritative fail. Once the authoritative fail, the resolvers at the ISP fail. So something has to be done from what we think at the beginning. Because the first thing that is happening is the query from the attacker over the DNS proxy to the resolver. And what we think is a good solution there is to actually filter at the ingress of the resolver. So, as said earlier, the attacks, the domains used in these attacks are around 1,000 at the moment. It will probably grow, but it's still not a huge number. And if you are able to distinguish the good from the bad traffic, which if you sort of have historical data on what has been resolved and not, is not that difficult to do, it's probably best to, if you get the first traffic on these random subdomains attacks, just drop it on the resolver, because then none of the authoritative will be actually affected, because the traffic will not go anywhere, because there's no recursion going on. And of course what you have to do, you have to protect the good traffic, so you have to have a whitelist. But as I said, mostly these domains have been using prefix of legitimate names, so as you saw earlier, it's www.baidu.com, and then the randomness comes in front. But even if the randomness comes at the first label that is used, if you have a couple of billion queries coming in every day, you know what legitimate queries are, and you can whitelist them. And in most domains, I mean, you have publicly something like 10, 20 names that are legitimate, and the rest, I mean, are NX domain. So you can easily digest that. And if you have the possibility, and we have that in our server to do that, a whitelist that kind of punches holes into a blacklist, which is what we do with that, then you can really drop the traffic. And as I said, what we have done is we've analyzing the traffic that we see from our customers, and when we get traffic that looks like a random subdomain, we do some kind of calculations, and we then put that domain on the list, and we push that list on the customers. And the round trip that we have for that at the moment are around between 30 and 40 minutes. So we want to get much lower, but at the moment it still is protecting the customers a lot, because some of the attacks resurfaces. So we have attacks that will run a day, and the next week they can run twice. And so it's just, it looks like it's kind of somebody pinching somebody to do something about it, or to get in notice that they can take them down. So the attacks are repeating, but not for long. I mean, as I said, most of the attacks 10, 15, sometimes 30 minutes, but not longer. So, and with that, I'm open for questions.
David Friedman, Clarinet. Do you have any software to share?
No, we sell our software. We are in that kind of business. So unfortunately, no. I mean, you have to buy it, but
thank you.
Greg Choules from 3. How are you going to have any piece of software which identifies something that is random? How are you going to create a filter which spots the random stuff, because by definition it's random?
Yeah, it is random, but there's an algorithm, some logic behind it. So one of the things that we are looking to, of course, first thing with these is we look at NXD, and then we look at NXD in the domain, and then we look if the prefixes has some commonality, and if then we have a bunch of algorithms in the background that we try to, well, it is that or this and it doesn't match, and then it's a machine learning system basically.
So you're essentially doing query log analysis.
Yeah, exactly. That's what we get. Our software has for a long time had the ability to log every query and to kind of not only log it but also kind of send it to other, because we have a central point. Our customers usually have lots of our servers, and then they aggregate the traffic to one point, and we then get some of the aggregation back to our headquarters and analyze it. Yeah.
Okay.
Okay. Thanks.
Okay, thank you, Ralf.